Hello guys, and welcome to our next tutorial where we are going to continue building the concurrent download manager. And again, this Golang code is based on Mohammed Usman's the concurrent download manager tutorial, so you can watch it first to understand the Golang code and then go back to our Python video. So what's the difference between the sequential downloader and the concurrent downloader? So with sequential downloader, we have a for loop and running this download section function in a sequential order. But with in order to add some concurrency here, we need to run this download section in download section function as a go routine. So this is basically the code portion that we have changed from the previous sequential downloader.go. And the addition here is this merge file. So the idea is we have downloaded this 10 file, but we need to give the user only one file. So if you download this 10 portion, we are going to merge it into the one file. So what this merge file here is doing is just opening the file, reading the sections. So we have 10 sections, finding each file, and then writing to the open file here, so to the target path. So the target path here is this file name. So you can change this file name and it will just write to another different file. That's it. And then let's just do this concurrent run. Go run concurrent go. As you see, the sections are no more sequential. So it applies some concurrency with go routines, and at the last it's just merging each file into one file. So let's just check if this file is here. Yes, we have this merged file, and the size is 5 megs, and that's exactly what we want. Now it's time to translate this concurrent code or do the same thing in Python using asynchronous techniques. I'm going to close this this thing. Nice. And now it's time to start with Python, but to make it fully asynchronous, we need to redefine our architecture. And I'm going to start from the main function here with just if name is equal main, then we are going to create this this struct, the dictionary here. I'm going to pass there's an empty list of the tasks where we are going to store this where we are going to store as asynchronous tasks, and as a final note we are going to run this main function. We are going to implement both, and the merge files and the latest addition, this merge file we are going to implement in the next. So that's it. Let's just start from the main function. So this main function should be asynchronous, then it should be async def main. It's going to accept this data is a dictionary type. It's going to accept a list. This is a list type, list of tasks. And again, the start time and end time. And returning these sections. So we are going to But now we need to import not request model. We are going to use this aiohttp and async IO. Nice. With aiohttp, let's just run it here. So we are opening the aiohttp client session as a session. We are updating this do function. So for asynchronous code, we are going to make the Python's do function here as an asynchronous code, and it will return this collective tasks and the sections. So then I'm waiting here with async IO wait for waiting the completion of this task. So from datetime import datetime. So if we have next function, the do function, again it should be asynchronous. So the signature of this function is, so it's accepting the dictionary, the data is accepting the session is the client session type from aiohttp, and it's accepting the task as a list as described here. And it returns a tuple, list and list. So we are going to return from this do function the sections and the tasks. So task is a list and the sections is a list of lists also. So it's a list type. And this is the standard things that we did it previously. So making connection and doing this get new request. But now this get new request is also the async code. And but the signature is the same. So we are passing the session and the URL and the method hit. Then we got the response status. This is the same, but let's just quickly implement this async get new request. What's the wording here? Nothing. So just quickly implement this async get request. So as the async def get request, the signature is that it has a method. So it's accepting the message. It's a string type. It has a URL. It's a string type, and it has a session. Again, it's aiohttp client session type, and it has a headers, which is a dictionary type, and the default is none. So what returns is a client is an aiohttp client response. So we are accepting client session and returning the response, as similar with sequential downloader. So there we have returned the request response, but here aiohttp client response. And what we have, we're checking that if headers, so if we did not pass, if we pass the headers dictionary into the get new request, we are going to update the user agent to string. Nice. And return the awaitable. So return the session. So we are doing the aiohttp session request with method equal to past method and URL equal to past URL, and the headers equal to the headers past headers. Nice. So get new request, not request. Get new request. Yeah. Nice. Then we what we have here. So we do the main. We have this check here. If response status, if response response status greater than, and we are going to raise this exception. So not status code, but status, right? It's a status. Then we need to get the size of the size from the header. So from the response headers, again this is the same. So get with content length and print this size. Initializing the list of lists, this is the same as previous, and printing the sections is the same as well. Printing the sections is the same. This for loop also is the same. Let's just type for. What happened here? Yeah, nice. And this print sections is also the same. It's just me. I just copy it here. Then we're going to implement. Yeah, we need to create a task, asynchronous task from this from this download section function, asynchronous code. So what we have here is just for index and section in enumerate from the sections. We need to append to this tasks dictionary async io create task download section. We are going to quickly implement it here. So let's just implement it here. So what we have, let's just complete it here. So download section is going to accept this index, section, data, and the aiohttp session, and we are returning. We are returning these as sections and as well as tasks. So what we have, so we pass this empty list to the main function. The main function passes empty list to the do asynchronous function, and then we are appending the asynchronous tasks into this list and returning from the do code, asynchronous do function. So we have implemented the get new request. The only remaining thing is I think is download section, and yes, the merge file function as well. So let's implement this download section. Async def download section. So it's accepting the index. It should be integer. It's accepting the session. It should be aiohttp client session. It has data. I assume it's a dictionary type, and no, section first. No, just oops. I'm going to grab it here, and it has a section which is a list type. Nice. Great. Then we are going to update the headers as usual with by giving the byte range here. So section 0, section 1 bytes, and the headers is a range. We are doing the get new request, but now we are waiting because this is asynchronous code. We get this response, and we need to print it. Right. Nice. So what's the next? The next is, as usual, so creating this. Is writing to this temp file. So I'm going to create a file name, but there's this difference between the sequential code which we run. So what's the downloader? So here we are just using the pure Python open function, so built-in open function, to write to the file. But this is a blocking action. That's why we need to asynchronous file write and read. So for that purpose, we have the special package called IO file. So we can't just open here the file and write into its response content as we did in sequential, because it will block. And if you have some blocking code, that means that there's no asynchronous code run in this context. I'd say. Let's just read the data. So the data is awaiting response content read, because the response itself returns the awaitable. We need to read this response with await. So it's a code thing, and we need to wait here for data. And just for opening and writing to the file, we are going to await IO files, open this file name, and again write a byte here, and then await fwrite the data, and then await fclose to close the opened file. This is how you write read and write to the file from the response. And so we read the response content asynchronously, we open asynchronously, and write into this and then close. So this is a non-blocking action. What we have next, what we left actually. So what's duplicated code? Nice. I don't care. The remaining thing is this merge files. So we run this in asynchronous async loop past the main. Have completed the downloading all sections, and now it's time to merge the file. But this is a non-asynchronous code, so we are just plain merging the file. So opening this target path with WB, but plus it means that we will append the bytes to the file. So this is the final file. We are going through these sections, opening file, and write write the bytes to the final file, which is target path, which is this is a final file, and we have this with it will close as a file for us. That's actually finally we have completed, I assume. So let's just recap. So we implemented the do function asynchronously. We are waiting from get new request. We are creating this tasks and appending to the list of from the download section asynchronous code. So with get new request, we are using aiohttp instead of the request module, and we are using async IO to run this asynchronous code, and we are using IO files module to write to read and write into the file asynchronously. This is how we can implement the download manager asynchronously in Python using aiohttp, async IO, and IO files. Let's just, I'm going to test this code. But first of all, I need to remove this section, things, and this 5 MB zip file. So what as output, what we have here, so as you see, there is no sequential run from the over sections. It's the same thing should happen for the Python code as well. So let's just run it. Making connection. Nice. So we did a connection. We got the response code. We divided it into the chunks, and there is no sequential run for the Python code as well. So process finished. Let's just see LTHR. Yeah, we have the same file, the same size, and also the temp files are there also. So we have asynchronously download the file by the portions, by the chunks, but the synchronously merge the files, and we have a final file as well. So this is a real world again example how you can do some asynchronous code with concurrent code with implementing the DOM loader with Golang, and this is to show how you can translate the same idea to the Python with some asynchronous code. So that's it for now, and I hope it will be helpful to you. In the next videos, we are going to do the same again, concurrent programming, but with different ideas, for sure. And yeah, see you in the next video. Bye.